Hello students, today I will continue explaining exercise 13.1. We have only 3 problems left from this exercise, that is question number 7, 8 and 9. Out of these 3 I will explain today only question number 8, and the remaining 2 exercises will remaining 2 problems will be your homework. Okay, that is question number 7 and 9 will be your homework for today. Okay, now I'm starting question number 8. It is given that from a solid cylinder whose height is 2.4 centimeter and the diameter is 1.4 centimeter. Okay, that means a cylinder is given whose height is 2.4 centimeter and the radius of this cylinder is given as 1.4 centimeter. Okay, now a conical cavity of the same height and same diameter is hollowed out. Okay, so a conical cavity, that means this conical cavity is hollowed out from this cylinder. So I have to calculate the total surface area of the remaining solid nearest to the nearest centimeter square. That means I have to calculate the total surface area of the remaining solid after hollowing out the cone from the cylinder into the unit centimeter square, and that will be an approximate value because it is mentioned here it will be nearest centimeter square, right? So since the conical cavity is of same height with the conical cavity, the height of the conical cavity is equals to the height of the cylinder, so this height is also 2.4, right? 2.4 centimeter. Suppose h is the height of the cylinder and cone, r is the radius of the cylinder and circular surface of the cone. Okay, so here h will be equals to 2.4 centimeter, it is given, and r is equals to 1.4 by 2 centimeter, that is 0.7 centimeter, because the diameter was given as 1.4 centimeter, so radius will be half of that, right? Now the question is, if I take out this conical cavity from this cylinder, then I will be having only this curved surface of the cylinder, and this much space will be hollow. If I see from the upper side, then I will see that this portion will be hollow, right? So if I have to calculate the total surface area of the remaining solid, then I have to calculate the curved surface area of the cylinder. With that I have to calculate, so I have to add the curved surface area of the cone, and again here I have to add the circular base of the cylinder, right? Which is equals to pi r square unit, right? Because this is r and the total one is 1.4, so this is zero point 0.7, right? This is the required total surface area. Okay, what's the remaining solid? Now the curved surface area of the cylinder, we know that is 2 pi r h. R is given, h is given. The circular base of the cylinder, it will be area of the circular base, that is also known, because pi r square, I can calculate that pi r square, it will be pi into r is 0.7. So these two things are known, but this one, curved surface area of the cone, here the formula is pi r into L. R is given, pi is 22 by 7 here, and L is slant height. This is the slant height. Suppose this is equals to L, okay, but this value is unknown for me here in this question. So at first I have to calculate the value of L. So what will be the value of L? See, this height is 2.4 centimeter and this radius is 0.7, right? So this is a right angle triangle. By applying Pythagoras theorem, we can calculate, this is the hypotenuse, which is actually the slant height of the cone, right? So what will be the slant height? L will be equals to root over h square plus r square, that is root over 2.4 whole square plus 0.7 whole square, because h is 2.4 and r is 0.7. This is 5.76 plus 0.49, that is over 6.25 centimeter, okay, unit. So it will be 2.5 centimeter. So the value of the L is 2.5 centimeter, right? Now I have all the values required for calculating the area. Now let's put the values according to the formula. The curved surface area of the cylinder, that is pi r 2 pi r h. Then curved surface area of the cone is pi r L, and the area of the circular base, that is pi r square unit, right? Now uh, 2 into 22 by 7 into 0.7 into 2.4, that is 2 pi r h, and 22 by 7 into 0.7 into 2.5 plus 22 by 7 into 0.7 into 0.7, that is r square. This is centimeter square, okay. Uh, now I just have to calculate this one and I will get the result. It will be 0.1, so this is 0.24 and this will be 2 into 5.28 plus this will be 0.1, that is 0.25 to 22, that is 55 0.5 plus, and it will be 0.07, 1.54 centimeter square. Okay, so this is 10.56 plus 5.5 plus 1.54 centimeter square, that is 17.6 centimeter square. So I have to calculate the value to the nearest centimeter square. It is given as I have to calculate in nearest centimeter square, right? So the nearest, that is approximate value here, will be 18 centimeter square. This is the required area of the remaining solid. Okay.